Let's check the next question. What is the next question trying to say, children? In the adjoining figure, segment DH is perpendicular to EF. DH perpendicular to EF. Segment GK is perpendicular to EF. GK is also perpendicular to EF. DH is 12 centimeter. GK is 20 centimeter. Area of DEF is 300 centimeter square. Area of this triangle DEF is what they are talking about. 300 centimeter square. That's area of the entire triangle they are talking about, mind you. I intend to find out EF, the entire base. Area of GEF, this is what area of triangle GEF, and finally area of quadrilateral DFGE. Now the last part is very, very simple, as many of them have predicted from right now only. The moment we get, sir, area of triangle EGF, we can club them together, add them together is what our last answer is. So how to get area of triangle GEF? Now if you just check, both the triangle have common base EF. Triangle DEF and triangle GEF have common base EF. Right? So first thing is what we have to find out EF, and how EF can be found out by taking help of the area of first triangle. Whose height is known, whose area is known, only the base EF is not known. Can you find out the area of triangle with formula half into base into height? Right? So we start off with our answer. What are the given things? The given things are DH 12 centimeter, GK 20 centimeter, area of triangle DEF is equals to 300 centimeter square. Let all these things should be placed in equation number 1. We shall write down this as given. We shall write down this as given. Now to start off with, first area of triangle. Area of triangle DEF. Children, what that is going to be? Half into base. Who is base? EF. And height, it is DH. Area of DEF is known to us. Area of DEF is known to us. 300 is half into EF. How much is EF? So that's what we need to find out. DH is 12. From where did I get these answers? From equation 1. From equation 1. Can I say 2 1 times 6 times? 6 comes down. So EF ultimately is going to be 300 by 6. 1 times 50 times. My EF is 50 centimeter. That's my first answer. That's my first answer, mind you. Second answer. Now there are many who might be thinking, and their thinking is not wrong also, I am sure to say, there are many who are thinking that, sir, why can't we find out area of this triangle, that is EGF, GEF, the below one. Since EF is now known to us as 50, which is acting as a base of the lower triangle, height is known to us. So again, half into base into height. Absolutely correct, children. Absolutely correct. So those who are thinking in that line, that we can apply area of triangle as half into base into height and do so, you are perfectly right. I would like to make use of the property which we have learnt recently. And what is that property? Ratio of areas of two triangles. So even if you get the answer which I said just now, half into base into height, you are perfectly correct, children. But I would like to make use of that particular property. Don't you think so? Triangle DEF and triangle GEF have a common base EF. Therefore, the ratio of the areas are proportional to the corresponding heights. I would like to make use of that property. So when I say for answer number 2, let this be my equation number 2. Let this be my equation number 2. For answer number 2, triangle DEF and triangle GEF have common base EF. When they have common base EF, property 1b, right? Therefore, can I say area of triangle DEF upon area of triangle GEF is equal to the ratio of the corresponding heights. Corresponding heights is nothing but DH by GK. What property? Triangles with common base have areas proportional to their corresponding height. So, what is the answer thereafter? What is the answer? Therefore, area of triangle DEF known to us. How much is it? 300. Area of triangle GEF is what we need to find out, children. How much is DH? Also known to us, 12. How much is GK? Also known to us, 20. From where did I get these values? From equations 1 and 2. From 1, we got 12 and 300. From 2, we got 50. In fact, I don't want, so it's only from equation 1. 300, 12 and 20. Everything from equation 1. So it's not from 1 and 2, it's 1. From equation 1 only. Now, we can directly cancel it off. Area of triangle GEF. Area of triangle GEF is 300 into 20 by 12. 300 into 20 by 12. 2 10 times, 2 6 times. 6 1 times, 50 times. Area of triangle GEF is 500 centimeters square. Area of triangle GEF is 500 centimeters square. Right? What next? I'm supposed to find out area of quadrilateral DFGE. That means the entire one. And we have discussed this earlier. Sum of the two areas. So what I'll write down? I'll just write down over here. I'll just write down over here, children. Third part. Area of quadrilateral. Area of quadrilateral DFGE. DFGE is equal to sum of area of triangle DEF plus area of triangle GEF. The reason is area addition property. Reason is area addition property. So just write down the reason. Area addition property. Mind you, this is what the reason will be. Area addition property. The area of triangle DEF is known to us 300. You can say this as my equation number 2. So equation number 3 rather. You can say this as my equation number 3. Area of GEF is what I got it. 500. From where did I get these values? From 1 and 3. Club them together. 800 centimeters square. Area of quadrilateral DFGE is 800 centimeters square. Right, children?